How's life, guys? Today's probably going to be the last concept of probabilities video, unless I find something new later on. Our task today is to understand binomial probability. Now, as we enter this concept, we would encounter some statistical concepts, which I'm planning to introduce to you guys soon. To understand binomial probability, we need to understand what binomial experiment is. A binomial experiment is an experiment where it is repeatedly held n times. It's not only happening one time, but we keep on experimenting the same experiment or the trial, same thing. And there's only two possible outcomes in this experiment, success and failure. For example, if we compare this to baseball, there is a probability where the batter would hit the ball or miss the ball, whether he could record an hit or an out. And all trials are independent in binomial experiment. One trial does not interfere with the result of the other one, as we've studied in the previous video. And lastly, probability of success is usually noted as P in binomial experiment. And now we meet another similar looking statistical word, which is binomial random variable. This one's really simple. It's just the number of times the success has came out in the binomial experiment. And the probability of success coming out from the total n trial is called as binomial distribution. Finally, we reached this stage. The formula here, as you can see, the purple drawing, or the equation, does give you a headache at the first glance, but it's not that difficult in the end. The formula is, as you can see, nk, this is, let me change the color here. This, as some of you may not know, is usually how we describe the combinations. So it could be noted, it's noted as nck. So we see nck multiplied by p powered by k, where p is the, as we've seen before, the number of time, the probability of success coming out, and q is the probability of failure. So, for example, in the flipping coin, the probability of success will be 0.5, 50%, and so will be the failure, 0.5. And so this equation, if we simplify the equation, this part here, then it will become nck, which is n factorial over k factorial, n minus k factorial multiplied by p powered by k, and q multiplied by q powered by n minus k. This is the binomial probability. Now we gotta remember this equation very well. There is a really easier way to solve this headache-giving equation, and that is by using a calculator, TI-84, 83, or much more advanced ones, which I am going to be making a video about it, explaining how to use it. But for now, I wish we all understood how the logic behind the binomial probability works. So let's look at our first example. Alpha had a batting average of 0.300. This is a baseball. In a baseball match. What is the probability of Alpha making 3 hits in 5 times at bat? So we need to figure out the N's and P's and other stuffs in here. So for example, what is N here? The total number of times the experiment is going to be held. N equals 5 times at bat. And what is the binomial random variable here then? That is going to be 3, and which we regard it as 3 times the k. K is going to be 3. The number of success. And so P here, the probability of success is 0.300, which makes the probability of failure is 0.700. So now let's apply the equation here, which is 5 times in total, 3 success. The ratio of success was 0.300. This is going to be happening 3 times. And then 0.700. This is going to be 5 minus 3. Now, let me change the color here to make it easier to see. Let's choose red. Now here we simplify 5 and 3. It's now regarded as 5C3, which is, let me make the full color here, 5 factorial over 3 factorial 2 factorial powered by 0.300 third 0.7002. We simplify this, which equals 5 factorial 3 factorial. That makes it 5 times 4 over 2 factorial. 5 times 4 is 22, which is 10. Now we need to figure out 0.300 cubed and 0.7 squared, which is 0.49. Actually, let me just calculate this here. It's gonna be 10 here. 3 times 3 times 3 is 27. So that's gonna be 0.027. 0.7 times 0.7, 0.49, which is equal to 0.1323. We change that to percentile, it will be 13.23% of it happening. I hope you guys get a clear understanding from this example, but the more the better. Let's go move on to the next one. Here, Alpha flips a coin 7 times. What is the probability that Alpha gets at least one head? When we see something like at least 1, it means you can get 1, 2, 3, 4, 5, 6, 7. It just doesn't have to be 0. Which means it makes our life easier if we calculate this through this way. 1 minus the probability of no heads. In other words, we can say only tails, but let's make it this way. So, let's assume that we're going to be having no heads at all. So, n is going to be 7. K is going to be 0. The probability of P and Q are equal, which since it's a coin, where there's only 2 possible choices, which is going to be 0.5. So let's make this into an equation. Combination 7, 0, 0.5, 0, 0.57. This is going to be, let me change the color here, 7 factorial over, this is going to be 7 factorial. 0 factorial is obviously 1 as we've seen before. So my 0, 7 factorial, which is going to be 1. So we won't be needing to calculate this part. So anything powered by 0 is 1, is always 1, which means this calculation will be simplified into 0.5 powered by 7, which is 0.0078125. That's a really small number. Now to get our answer, we have to do 1 minus P of no heads. What we got here is probability of no heads, which means we have to do 1. Oh, this is too dark. Let me change it to a brighter color. Pink would work well. 1 minus 0.0078125, which equals to 0.9921875. That's it for today. Thank you for watching. Please like and share the video if you liked it.